forget, in the last class, we started this project, and we did the initial setup. Then we created the services. We just did a few things like to set up the project. All right. So today's class, we are going to build upon what we did in the last class. We are going to create the models. We are going to continue building the models because that's where we stopped the last class. And then when we are done, we then handle the actual registration, password hashing. Then I don't know if we'll be able to complete the login. All right, in this class, maybe that is going to be in the next class because registration and login is supposed to cover 2 classes. But let me confirm that. Okay, so that's supposed to cover 2 classes. All right, so we will do as much as we can in this class, and whatever is left will be covered in the next class. Okay, I believe you can all hear me, right?
Yes, I can hear you. Yes.
Okay, that's perfect. All right, so in the last class we created this users model. All right, and this users model is supposed to store the user information. The users that sign up on our server. All right, so we want to collect the username. We need the email. We need the first name, last name. Then the last time the user logged in, that's 11. We'll capture that soon. Then we are not going to store the plain text password. We store a hashed copy of the password. That's what we have at line 12. Then at line 13, the phone number. Line 14, day of birth, date of birth. Oh, no. That should be month of birth, not date of birth. So I'm going to change that to month of birth. Then we have year of birth. Then the last thing is email verified. We want to check if this user is actually verified, if the user's email is actually verified before granting access. So the verification status is stored there. Now, one thing you need to notice, in Toto's ORM, when creating your model fields like this username, you apart from this max length value here, which defines the maximum length of data that is acceptable at that particular field, you can also set if this field can be null. Like what this means is that you may be asking, like, if I create a user, all right, can this particular field, can a user create an account without a username? Right. So this is set to be true so that we can basically save anything to this database, like to this particular table. All right, we don't have to input all the information. So I love to do it this way. All right, but when the user is actually creating an account, like when the data is coming in to the endpoint, we'll use Pydantic. We'll use Pydantic to handle the validation there. Okay, so if the information we expect to collect is not supplied, we didn't throw the error there. Right? But I don't like doing it at the database level because if let's say we specify the checks here, let's say at this particular table we set that this username should be provided, and then we don't specify the checks at the endpoint. If this data is not provided, it will throw an error. Like we'll have an internal server error at the back end. So that's that. Now we are going to create a table for tweets. Yeah, we are going to create a table for tweets. And before we do that, let's create a table for the image that we want to store. So we'll create, let me call this table picture. And it's of course going to inherit from base model. Then I want each picture to have a user, and the field will be shared. Want to give something. Good. Okay. This one. Now, this is what we call foreign keys in all right, so there's what we call foreign keys in SQL, all right, and SQL databases. You know, when we are creating a table that is supposed to be linked to another table, take for example this pictures table, right, which is supposed to store our profile pictures. Right, when this picture is created, we should also be able to identify the user that created this picture. All right, that means this picture table is in a way linked to user table. Right, for every picture that's supplied, you need to know the user that has this particular picture. Hence, the need for this user field. And this user field is like a foreign key field because it is linked to the other table. Then we are using this foreign key. You know, we have many kinds of relationships. Right? We have one-to-one relationship, we have many-to-one relationship, and many-to-many relationship. The one-to-one relationship means that, let's say, in the context of this particular project we're working on, a one-to-one relationship between the user and the picture means that the user can only have one picture, and one picture can only have a user. Then a one-to-many relationship basically means that in the context of this, it means that each user can upload multiple pictures, all right? But a single instance of a picture, like a single picture, can only have one user. So that's exactly what we are doing here, all right? This foreign key field, it is always available at the many side, all right? So in this case, one user can have many pictures because this foreign key field is at this picture level. So that's that for one-to-many. Then we also have many-to-many relationship, and we are not going to need it at this on this particular project, but you may actually come across it later on. In such situations, a many-to-many relationship means that take for example, if the user and the picture was like a many-to-many relationship, it means that one user can have many pictures, that can upload many pictures, and each picture can have many users as well. All right. So the many side is on the user and on the picture as well. That's why it is many to many. All right. So we have in this particular table we have the user field, which is a foreign key field that links to the user. Then we also need to have the URL, which will be a chat field. So I'll copy and paste that. And I want this to be 500 characters. All right. Then we also need to have okay, I'd love to store the file name as well. Though this is not strictly necessary, but I just want to store that too. Then finally, I would love to store the file size. Yeah, the max length of country should be not file name country should be, you know, change that to 200. The file size country should be not. Okay. So this will happen. I think I explained this earlier in the course that we usually don't store the picture right in our database. Let's take for example Twitter. Like when you upload picture to Twitter, it's not stored in the database. Right? It is stored on that's what we call block storage, static storage, and We have services that help you do that. We have services like Cloudinary. We have services like Amazon S3. Then we also have Google Cloud Storage. Right. What these services do is that you link it to your application. Take for example, if we are using S3, Amazon S3, we link it to our application such that when a user uploads a picture, right, we then get this picture, then send it to the bucket that we have created earlier. The bucket we want to store these pictures that we have created earlier on the Amazon and the AWS S3. Then when the upload is successful, we then get the URL to that particular picture. Now it is that URL to that picture that we are going to store in this URL field. Then the file name, I think we did this earlier in the course when we work with images and when we work with files, file uploads. So when someone uploads a file, you can extract the file name from there. So we extract the file name and keep it here. Then we can also extract the file size and keep it here as well. Okay, so I would love to pause for questions. Do you have any question on I think the area that will be most could be more confusing is when I explained this foreign key field and relationships in SQL. Please, do we have any questions on that before we start creating the models for the tools?
Okay, I hope my background is not too noisy. Based on the main table, the first class you created, user class. I know in SQL there is the main table usually have, just like you mentioned, foreign key. There's also primary key. So I know like in this, when you have a main table, there's usually a primary key. There's supposed to be at least one column where every value there is unique. There's no repeating value. So I didn't see you identify any primary key in this user table.
Okay. I understand your question. So please don't forget that at the base, right? Don't forget we created this base model. And this particular model contains the keys that we want to share across each and every model that we are creating, right? So this base model inherits from photos of model, right? Then this base model contains an ID, a field ID, which is a new ID field that is new.
Okay, yes, I get. Just right now.
Unique, like this is the primary key. Then it is created as, which is a datetime field that is automatically created when that record is created. Then we also have an updated field, which is a datetime field that is automatically populated when this field is updated. Right now, we took this base
Sorry, I didn't get what you said. I think the network. I didn't get what you just said. Can't hear. Hello? Yes.
You can't hear us. His network is bad. Just wait a minute.
The line close the base. All right. Now each. Okay. All right. So we have defined the base model. Hello, can you still hear me?
So, sorry, I wouldn't hear you for a minute. Yeah, so we lost a lot of stuff you said.
Yes, sir, like the past 1 minute.
Okay, but you can hear me now, right?
Yes, I can hear you.
Okay. Sorry about that. So what I was saying is that we created a base model, a base model that contains the fields that we want to reuse across all of these models. And this base model contains the ID, which is the primary key, the created at, then the updated at, and this user's file or this user's model, we imported that base model, right? And each model we are creating, like the user and the picture, directly inherits from that base model. So it gets the fields that we defined there. So even when you don't see ID here, you don't see created at here and updated at here, they are they will inherit those fields as well. So that's it.
So I also have a question, please.
Okay, please, what's the question?
In the picture class, where you talked about the URL and the file name, the file name and the file size. You see, are we going to be extracting that manually, or is it going to be done automatically?
Okay, it's done automatically.
Let's talk about extracting the file name and file size.
Yes, it will be done automatically. I think a couple of classes ago, when we looked at file uploads, I showed a method where you can use to extract the file name from any file that is uploaded to the server and the file size as well. So we are going to use that method. So how this flow will work is that when a user uploads a picture, we will get this picture and we'll extract the file name from this picture that is uploaded. We then extract the file size from this picture that is uploaded. Then we are going to mimic an upload to AWS S3, but I am not going to do that because, of course, I don't have access to S3. Though I have an AWS account, I don't think I have enough credits in my accounts to actually create these resources. So we are just going to mimic an upload to AWS S3 and then return a URL. Then it is that URL that we are going to store there. All right, then the file name we extracted will be stored at the file name field, and the file size we extracted will also be stored at the file size field. So that's how that will work. And of course, the user, so the user that has this particular picture will be stored at that user field. All right, so now let's go to the next. All right, thank you. Let's go to the next file. At this file, we want to create the models that relates to the content that we are going to use on our server. Don't forget we are trying to make Twitter, right? So in Twitter, people can create tweets, right? People can like tweets, people can comment on tweets. So on this particular module, we want to create the database support for this kind of operation. As usual, we are going to import fields from Tortoise. I need to separate this. We are going to import fields from Tortoise. So from Tortoise, import fields. Then we are going to import our base model from models of this. All right. Now the next thing we are going to do is to define a tweet model. And of course, tweet is going to inherit from base model. So that's that. All right. Now, of course, each tweet should have a user. All right. And one user should be able to submit multiple tweets. So what we are looking at here is a one-to-many relationship. All right, where the many side is on the tweet. Don't forget, we have only one user that we have that one user can submit many tweets, can post many tweets. All right, so the many side is on tweets. That invariably means that we are going to create the foreign key field on this tweet model because that's the main side. So we are going to, I think let me just copy and paste here. All right. Then we have user is equal to fields or foreign key field, and it is related to model.user. which is this particular this particular model, and the latest name we want this to be tweets. Now we want this particular field to be nullable. That's why we set here that null is equal to true. Now each tweet should have a each specific tweet should have yeah, I think we've all been using Twitter. So what and what do we have on Twitter? There's each tweet. We normally have the text body, right? Apart from that, is there any other thing? I don't think so. So I am going to create content. This field will store the content of the tweet, and is going to be a char field. There's a character field. So field the char field, and I want the max length to be 600 characters for each tweet. Then this should also be nullable. Null is equal to true.
Yes, you can also accept media.
Okay, media. I don't want this to be very, very complex, so we'll ignore media for now.
Okay.
Yeah, we'll ignore media for now. But that is very possible. In that case, all you do is to create another field that inherit from tweets. Okay, no, that does not inherit from tweets. We'll create another field that has a one-to-many relationship with tweets. There's a many side will be on that field, the media field, because one tweet can have different media, so it can have many medias. So that's what we would do in such case. But in this one, I want it to be simple. So we are going to ignore that. I guess that is all for tweets. Yeah, that should be all. Now, each tweet, we should be able to like each tweet, right? So we are going to create a field for like. We are going to create a model for like as well. And as usual, our model is going to inherit from this model. And of course, tweets do have share as well, but no, we are not going to do that. We're not going to do that. Maybe I'll give you that as an assignment to work on. So now each like doesn't need to take a whole lot of things. All we need to capture for likes is the tweets that we are liking, right? So we need a field for tweets, and this will be a one-to-many relationship with this tweet table. Okay, so that's that. Tweets is equal to field of foreign key field models of tweets. Okay, we are linking to this particular table. The related name is likes, null is true. So what I'm doing here is that each tweet can have many likes. All right, but each like can only be linked to a single tweet. And that's why there is this foreign key field at the like branch of it. Now, we also need to know who liked a particular tweet. So we are going to capture the user that created this like. So that is also going to be a foreign key field because we want the user to be able to like many tweets. This will be models.user. Then the related name will be equal to likes. Then null should be true. So I guess that's all for like. What else do we need? What else do we need? Yes. Users should also have the capability to comment on a tweet. When you see a tweet you like, you should be able to comment on that. Say, hey, this is nice and all of that. So we are going to create another class, and we'll call this comments. Which is still going to inherit from base model, and this will be the tweet comment. And each comment will have a tweet and the user that submitted the comment. Then each comment should also have the content of that comment, right? What did the user enter as the content? So we are going to copy the content from tweets. What else? What else do we need? What else do we need? I believe that should be all for comments.
Yeah, I think that's it.
Now, finally,
the related name.
let's break down media.
You didn't change the related name, sir.
Comment. Sorry. Please, thank you for that. So this. Yeah, this will comment. So, okay, let me create a field for media, so that we want to just create the database support for a tweet to have images. To do that, we will create another class and then we'll call this media. And of course, it's still going to inherit from base media. And each media will have our host redirect, the URL, each media will have a URL, it will have a file name, it will also have a file size. Then it should also be linked to a particular tweet. So I'll simply copy that and paste, then we'll change this media. Yes. Wow. So I believe with this, we are done with the models. I believe with this, we are done with the models. So is there anything we've missed? I don't think so.
So, sorry, a little question.
Okay.
Yeah, I was wondering. Can you hear me?
Yeah, I can hear you. I can hear you.
Okay. I was wondering, on the comments class, is it possible to inherit the tweets class rather than the base model? Does it can it work like that?
Exactly. I think I had a
fields are
question like
almost the
that.
same thing.
Okay, at the comments so that you can inherit the tweet class instead of base model. I don't think it would work, and I really don't see any reason why we would want to do that. Actually, I don't see any reason we would want to do that actually. But it may work, but I really don't see any reason why we want to do that. Since we need each comments to be linked to it, we just need to create a foreign key, like a relationship between these two tables, so that each comment will have a tweet that is attached to.
Okay, sir. Also, the second question is the all the classes are inheriting the base model. That means all the classes will have this UUID field in all of them.
Yes, yes, yes. That means that all the classes will have this field ID, which is the primary key. Then it will have, they will also have a created at field and an updated at field.
All right, sir.
Wow, so I believe that is all. Now, the next thing we are going to do is we are going to define each of these models we've created. We'll define it at the init, the I see this init file. We are going to define them there, and the reason why we're defining them there is that so that our age, the migration tool we are using will be able to identify, they'll be able to pick all these models. Right. If we defined all these models in one file, right, we could have just pointed age to this file. Let me show you what I mean by it. If you look at our database file, can you see these models at line 17?
Yes, I can see it.
Can you see this at line 17? Yeah. So
Yes.
this points age to the module that has our models, right? The models that we have defined. So since we have a whole lot of files that contain these models, we have users, we have contents, and I think users and contents. I don't really want to like point it to the exact this thing, like something like models dot users and all of that. It doesn't really. So instead, these models represents this package, this models package. So for Erich to actually identify each and every models that we have defined there, I'll just import these models into this image so that Erich will be able to see them. So that's what we are going to do now. I don't remove this, copy this to this, copy this to this. So we're going to import users and pictures from models.users. So from models.users import user, then it also import picture. And we are also going to import tweets, like, comments, and media from models of content. So from models to content, import tweets, like, and we also need to import just tweet like link, comments and media as well. So comments and media. Then we don't want flip it to check this particular file. So all right, so we don't want flip it to, like when we are running static analysis, we don't want flip it to check this particular file. So that's the reason for this comment on top of the file flip. It's no cap, like no quality assurance. What that means is that this file should be ignored. Why it should be ignored is because normally if we run flip it will throw errors, because number one, we have imported this user and picture without using them at this particular model. So we've also imported tweets, likes, and all of this without using them at this model. So we don't want those errors. Hence, like instructing flip it to ignore this file. So that is that. I think with this we are ready to create our we are ready to instantiate the database and then create these models. So I'm going to copy and paste the commands that we need to do that into this node file. Then when I'm done with that, we'll then use the commands. Okay. All right, so these are some of the commands we'll be using. The first one is build, just to build the container up, down, create, super compose. We don't need this dev up and dev down, this good. So let me change this to prod up, and this is Docker compose prod. That's when we want to build this container in production. All right, we can run this command make prod up. So if you're using Linux, you do that with this map and under down, which in this case is Docker compose down. But if you are using Windows, make is not installed by default on Windows. So you can go ahead and install make, or you can just let's say you want to run a single command, you just come and copy and paste like this. You can simply copy and paste if you're using Windows. Right, so that's that. I just want to list all those commands here for you so that you can reference them in one free time. Now we need a command for black. And we'll also need a command for it. Here, so Windows in. Okay, so Docker compose Docker compose run main. In our case, our service is Twitter, not main, so we'll change this to Twitter. Let me confirm that. Yeah, the service is Twitter, so we'll change that to Twitter. Then after running the service, we should go into the terminal and then run it. Then need a command for block. Twitter. Okay, Twitter. Now, if it should be here. Good. So this is a command that will run often. Message. All right, so now we're doing the command for DB init. There's a command we need to initialize the database. There will be this. All right, init DB will run Docker compose. We don't need to reference a specific file, so remove that mistake. And I want it to run the Twitter.
Okay, sorry, I'm not seeing your screen again.
Oops, it's like my
Got
network is
disconnected.
connected. Yes, yes, I was disconnected. Sorry about that. Let me go back. Okay, so where did I stop?
You were typing some things, though I didn't see. It's as if you were typing it outside VS Code because I was not seeing what you were writing.
Okay, okay. Okay. So I was I want to create, okay, I want to define the command that we want to run to initialize our database. So we want this command um, to be under initdb, right? So when I run initdb, I want it to execute all these commands. Now, the first thing we need to do is to like point a reach to this particular configuration. I see this tortoise ORM. We want to point age to this tortoise ORM configuration because this will enable age to get access to the database and run the migrations and all of that. So to do that, we need to specify where that particular file is. All right, and that particular file is at library dot database dot another database then dot the tortoise ORM. So I'm going to now edit this command, and in front of this database I will input library. All right, then when the init is done, we want it to actually create the migration and execute the migration. So we are going to edit the second command for that. Good. Now we are actually running the Twitter service, not main service, so I'm going to change the name to Twitter. Then it will like go into the terminal and execute a reach initdb. Then when we want to run a migration, what we have to do is simply run dd migrate, and that will like again run the service, then go into the terminal and then execute a reach migrate. So I'll change this from initdb to migrate. Now the next thing we are going to do is to edit the upgrade command so that it will change to this reach upgrade. Great. All right, so these are the commands we'll be using. Now let me go to the menu. Yeah, let me go through the menu. Now the first command is build. All right, when we are building our container, like when we started the project and wanted to build everything, install everything, yeah, we use the build command. Now up is for when you want to start the container, down is for when you want to delete the services, and create is non-management. Yeah, so I'll take it off. Then prod up is when we want to start the services in production. Just when we are done developing and we want to start in our live server environment, we use that one. Now, prod down is when we want to like delete the services in production. Now, prod build is will be used when we want to build the services in the production environment. Now, restart is when you are restarting the services. Okay, I don't think you're going to need that, so I'll get that off. Then start too, we will not need that, so I'll get that off. So the comments are a little bit incorrect at the moment, so I'll leave it for now. But later on, I'll go in there and edit these comments properly so that the right message is passed across. Then, as for the last 4 commands, like black, you know, when we started this project, I said something about black, which I told you is a library in Python that we use for code formatting. All right. So these are the commands that you use to. This is the command that you use to execute that code formatting. It's Python and it's in black. Then you can specify the line length. Like what that particular flag does is that you want to specify the length of each line of the code. Then what should be the maximum line length of the code? In this case, I want it to be 79 because that's like the official, that's the recommended line length for Python code. So it then formats the whole code automatically for you. Now this Docker compose run Twitter /-c. What this does is that, you know, we are building this code in a container, right? So before we can actually run this Python -m black code inside the container, we need to start this container, then go into the container and then run that code. So that's what this earlier part of the command does. Docker compose run means start and run the container. Now, which service do you want to start? In this case, we want to start the Twitter service. All right. From the list sh -c means go into the Twitter service and then run these commands that we have specified within these quotation marks. So that's basically the same thing for the init db migrate and upgrade. Then as for init db, let us go to the rich documentation because these commands are listed here. You can reference them at one time. So there's that. Now, rich. Can you see my browser?
Yes, I can see your brother.
Okay, so we are going to the rich GitHub repo. So it describes how you can configure a rich for a project. Right. So if we scroll down, it explains the database migration to database ORM, which is calling before SQL Alchemy. So SQL Alchemy is another ORM. Is another ORM, object relational mapper, just like Total's ORM, right? And it has a migration tool that's called Alembi. So this area is to Total's ORM, like Alembi is to SQL Alchemy. Then it also explains how to install it, which is pip install erich. Then these are the list of commands that you can use. All right. We have downgrade, that's erich downgrade. It downgrades to a specific version of your migration. Now we have history, which lists all the migration items in it, initializes the config file and generates root migration location. So that's what we did at our first command, erich init. Then init db generates the scheme, and so init db basically generates a scheme. Now, if you scroll down, you see the usage. Can you see this auto store? And this is basically what we did in that database of py5. Then, if you go down, you see the initialization, like everything. How to init the database, like init db, how to like run a migration, erich migrate, you can specify the name. Then you can also apply the migration with erich upgrade. So that's how it reach. I would recommend you go to this GitHub because so that you have an idea of what it really does and all of that. So please, do we have any question on this so far?
Wow, this has been a mouthful, but but it's making sense.
Yeah, it's a lot.
It's huge. It's
Lots to
huge.
practice.
Yeah. So
We'll go through it later and get more
yeah. So
understanding.
yeah. You can thankfully, though at the moment this video is not streamed, so when it's up live on YouTube, you can go through it again. So what is going to happen now is that my battery is running low. At this point, I'm going to shut down my system and then change my battery because I have two batteries. I'll change the battery to the other one. Then when I come back up, that should be within 5 minutes or so. Within 5 minutes or so, when I come back up, we are going to run this command, this initdb, to actually generate the schemas and then create these tables actually in our database. Then we are going to go to the database, like we're going to boot up the database, go through it, and then run the SQL code to actually display the tables that we've created. And after that, we start creating the endpoints for the user registration. Okay, I hope we're all there.
Yes.
Yes, sir.
Okay, so I'll be off for, let's say, 5 minutes or so. We are going to now execute this and see what happens. All right. I don't know if it will work, but I'm afraid it works. So I'm going to run this initdb, right? And if we have errors, we are going to work towards fixing the errors. But I don't think we should have any error because everything is okay. Library.database to database, database one, library, database. Yeah, we shouldn't have any issues. So let us run that and see what happens. Make init db. So if you are using Linux, all right, you can just execute make init db and make will run this first command, right? And when that is done running, it will run this second command. But if you are using Windows, you will need to, okay, if you are using Windows and you don't have make installed, you will need to copy and paste the first command, and when you are done, you copy and paste the second command. So let's do that and see what happens. Oops. Yeah, so everything ran successfully. That means we will not have any errors. Yeah, it was successfully. That means we don't have any errors, nothing to fix. So the first command, Docker compose run Twitter, it booted up, like it started the Twitter service, like you've seen here. Container, this started, container, this started. So it started the Twitter service, and then it went into the command line and executed this command reach init -c, blah 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 blah. We then initialized the database, passing the database configuration from this particular file to it. Then this particular command created this. So can you see this file on my screen? So this,
Yes.
yeah. So this is the rich configuration file. So it defines the way the database connectivity is. That is at line 2, which is at library.database.database.database. Then it then defines the location of the migration files, which in this case is /migration, meaning at the base directory there should be a migrations folder. All right. Then it then defines the base directory, which is still the same directory. Now, if you go to the migration folder, you will see another models folder, and within that models folder, we have like all these fields that we created earlier. This is what I mean. I remember the users field we created.
Yeah.
Yeah.
Yes, I remember.
Yes, like this particular users field with all of this. So what happens here is that Eric goes in there and then interprets that Python code that we have there. All right, it interprets it to SQL. Okay, our database doesn't understand Python; it understands SQL. All right, so it interprets what we have there, and the first command create table if not exists user. What this means is that this is the SQL that we use to create a table if that table does not exist. Right. So in this case, we don't have the user table in our database. So if this table does not exist, create this table. Then it then imputes the fields that we need to create. So let me divide my terminal into two so that we can compare the two. This is what I mean. Good. It then goes ahead to create fields. Can you see this ID field? Don't forget this user field inherited from base model, and this is the base model. And the base model has an ID field. It has a created and updated. So that is why we have this ID. We have this created and then we have this updated. And if you look at this base model, the ID was supposed to be a UUID field. So this is the data type UUID, and it is not supposed to be null. It's not supposed to be null. That's why we have here not null. Then it is supposed to be a primary key, like we defined here. That's why we have primary key here. Now the created is a datetime field. That's why we have this. Then it's not supposed to be null. That's we did not include null is equal to true. So that's why we have not null. And it's supposed to have a default value. All right. Auto now add is equal to true. That is why we have this current timestamp, and the same thing with updated at. Now, that then brings us to the fields we defined under the user table. We have the username, which should be we should have a max length of 50. So, and it is a char field. That's why we have a username varchar with in bracket 50. That 50 in bracket is the max length of data that this particular field can carry. And this varchar is data type. All right, in SQL it's varchar. Now we have an email. We have first name, last log, which should be a datetime. Then we have hashed password, which is still a varchar, phone varchar, and email verified is a boolean field. As you can see here, email verified is a field .boolean field with a default of false, and all these fields are nullable. That's why we don't have this not null present here. So we then wrote a comment on table user is user table. That is this comment that we had inputted here is what we have here. Now, can you see this semicolon over here? So this semicolon means it's an end of statement in SQL. I think we have something like this in JavaScript too, but in JavaScript it's not compulsory, like it's not necessary. You can exclude the semicolons in JavaScript. Then in SQL, when you are ending statements, you end it with a semicolon. So that's the end of that particular statement. Then we then created a picture table. So it's the same thing, an ID, created that, updated that, and URL and blah blah blah. Now, something very important. Can you see this foreign key? We defined the foreign key this thing here. So in SQL, it actually stores the ID. All right, it stores the user, whatever you named here. If we had used maybe user Y, here would have been user Y underscore ID. Okay. Now it is of course a UUID field because the ID of this user table is a UUID as defined here. The ID is a UUID. So that's why we have this UUID. Now this references is like it's telling us that this particular field is a reference to another table, right? And what table is that? It's a reference to the user table. And what in the user table are we referencing to? We are referencing to the ID, right? So that's what that particular thing says. And as you can see, we have this on delete cascade. What this means is that whenever a user is deleted, there's the table that this particular table is related to. When that particular record is deleted, this record in our pictures table should also be deleted as well. That's why we have on delete cascade. So let us say me, 18 created an account on this particular website, and I didn't upload the picture, right? If I delete my account, all right, since the relationship between the user and this picture is set to on delete cascade, it means that if I delete my account, the pictures that I created will be automatically deleted. Okay. I hope you're all following me.
Yes, we are.
Yes, sir.
Okay, do you understand what I'm saying, or should I explain it?
Yes, I understand at
It
least.
makes sense. It makes a lot of
It's
sense.
true. Yes, I understand.
Okay.
It's cool seeing the SQL implementation. It's really nice.
Yes, it's nice. So what Toto is also is it just this what we are doing is Python. We are working with classes and we are inheriting from classes. We are defining class parameters and all of that. And your SQL database doesn't understand that. All right. So the ARIT just takes all of this and converts it all to SQL code. So that is what this first command did.
Sorry, sir. The on delete cascade, it was automatically added there. Is there a way to override it if we want to preserve a particular table?
Yes. So if you want to preserve a particular table, by default, it is set to delete. All right. If you want to preserve a particular table, it would have been I think it's on delete. Let me confirm from these docs. Oops. Good. Can you see this? Foreign key on delete.
Yes.
So you can select one of on delete cascade. Indicate that the model should be cascade deleted if related model gets deleted. Then field or restrict indicate that the related model delete will be restricted as long as the foreign key points to it. I've not really used to this particular one before, so I'll need to read the documentation about what this particular one does. But the alternative, like the direct alternative to onDelete cascade is onDelete set null. All right, it sets that if let's say if the user is deleted, all right, instead of deleting this profile record, instead you just set this user to null. Right, you just set this to null. So in that case, it would have been onDelete is equal to set null. I believe this should be a syntax, by the way. Sorry, let me confirm that. Good. So this is how you would have done it if you wanted to preserve this particular relationship.
All right, sir.
So that's how it is. But in this case, we don't want to set it to null. Instead, we want this to be deleted because I don't really see need for me to preserve the picture when the user is gone. But there are certain instances in which we want to preserve that data. Right? But in this case, we don't need to. So I'll just name that up. So basically, that's what happens. That's what happens. Now we are going to go to the database proper and then inspecting these tables we actually created. Let me switch to the terminal. Then we'll work from the terminal. Okay, so first we need to see the containers that are actually running, that are running at this point. You do that with docker container. Yes. It will list the list of containers that we currently have running. We have to run this. That means our container is not running. So to get it to run, we will go back to our VS Code, then we'll start the project. Okay, so I'll run make up. This make up will execute this command. Can you see up? It will execute docker compose up. So what that command will basically do is to start all of these containers. So if I execute that, yeah, it will start all our containers. Yeah. Now let's go back to the terminal again and try that again. Good. I'll play that. Then I'll run this command again. Docker compose. Yes. So as you can see, our containers have been started. We have this. We have class 18 Twitter, that's the main service. Then we have the Redis container as well. Then we have the database container. So I'm interested in this database container. So I will go into that database container and execute some SQL code. So we do that with docker exec, then minus IT, that's docker execute, and which container do you want to execute. You then copy the container ID of whichever container you want to execute. So I will copy the ID of the database container. Then I'll paste it here. Then what do you want to execute? Is it bash? I don't want to go into the bash terminal. I want to go into the Postgres terminal without the PSQL. What is our username? It is of course Postgres. And what is our DB? Is of course still Postgres. So if we do that, we are now inside the container, and we are now inside the Postgres terminal. Does you have a question on this?
Is it Postgres container or Postgres database?
Okay. It's a Postgres container actually, and it is a container that is running the Postgres database. So if you are using Postgres container, you are right. If you are using Postgres database, that's right. The container is like, when we say container, when we use the word container, we are like referring to a virtual machine. It's basically a Linux machine, a Linux virtual machine that has the Postgres database installed in it.
Okay, sir.
Okay, please.
Yeah.
Do you have any
Yes.
other question?
Yes, I have a question, sir, with this particular step. So while I was trying to do the assignment, I
Yeah.
I tried to change some parameters and values and just play around basically to see, try and understand the whole process. So the username, I renamed the username. Instead of using Postgres, I used a different name. And though everything
Yeah.
compiled and everything ran properly or built properly, when I came to inspect interact with the database with this command, I was getting an error, like it refused to go through. So I don't know
What error
if,
did it exactly?
okay, let me just read it exactly as it is. And let me just read it out so that it says something about, where is that? Not something about roots not found or something.
Okay, it's not found.
Yes,
Okay,
like say,
what you should do is when maybe at the end of this class, you should screenshot the parameters you had used to create the database, like the user, the password, and all that. You can screenshot it to me. Then you then
okay.
screenshot this command that we used and send to me on Slack so that I can debug for it.
All right, sir. All right, thank you.
Okay. No. So please, do you have any other question apart from that?
No question from me for now.
Okay. All right. So to check the tables in PostgreSQL, you run /detail. This will list all the tables that you have. You can see here we have the comments table, like, media, picture, tweet, and user. That means these tables were actually created. Now to inspect an individual table, you type table, then the name of that table. In this case, I want to look at the user table, and don't forget this. Don't forget this semicolon at the end. Table user syntax error. Why the table user syntax error this name? Creation users, there's this. Yeah, we don't have users. Syntax error as only user. Wow, that error is strange.
Are you trying to return the table?
You know, I want to check.
Maybe you just have a, what's it called?
You said what?
Maybe put it in a quotation mark.
Sorry, I can't hear you.
I said maybe you should put the users in a quotation mark, like table quotation mark users.
So no, it's not supposed to be that. Okay, let's try it. Oh. You're right. Sorry. Sorry about that. You're right. Who is that? Who made that suggestion, please? Please, who made the suggestion?
Sir, there.
Okay, there. Oh, thank you. Thank you. Thanks for that. So that's the mistake I did. I didn't put this in a quotation mark, all right? So that's why we had that error. And when you want to inspect an individual table, you first you type the command table, then in quotation marks, you input the name of the table. Let us try tweet. Then you then put in your semicolon to end the statement, and it will list the the fields available for you to manually inspect. So I guess we are done with that. Now let us exit this and go back to our video screen. Now let me shut down the components. Wow, so we've gone very far today. We've done a lot today. I think so far today we created the models that we needed, and we instantiated a rich, created the schemas and ran the migration. Right. So that is that for the database. Now the next thing we are going to do is to create the endpoints that will actually handle the user registration. All right. So we are going to create another folder that will handle the routers that we'll be using. So we'll make directory, and I'll call this directory routers. And oops, no, I don't want it to be direction inside this project. So we'll delete that, and we'll create this inside the Twitter directory. Okay. Now within these routers, I want to create a set of routes that will handle, that will deal with authentication. Right. So within this router folder, I'll create another module called author. Then of course I need to delete. All right. So within this pod.py, we are going to import I think it's called API router from Fast API. So from Fast API import API router. API router. So this is how you structure each project, like large project. In previous examples, when we wanted to create a route, we just did it like this. We instantiated the Fast API application, then we used it to like decorate an endpoint and all of that. But when you are working with a huge project, all right, you can't keep on creating all your endpoints on a single page, all right, on a single module. It will be unmaintainable code. It will be very difficult to maintain. So instead, you can break down your routes, all right. Maybe in this case, we need the routes that are that we are going to use for authentication to be stored in a separate module. There's the authentication module. Then the routes that we'll use for profiles, like update of profile, delete of account, and all of that, we want to store it in a separate module. Then the routes that we're going to use for tweets will be stored in a separate module. So in that case, we are not going to instantiate this Fast API in each of those modules. All right, you instantiate Fast API at the base of the application. So you may be wondering, like, how do we decorate those other endpoints as well? All right, we simply do it with this particular API router. You import API router from Fast API, then you instantiate that router. The router is equal to API router. We instantiate it. You can pass in some things like dependencies. You can pass in. I want to pass in something. There's something I'm looking for. Yeah. Including schema, and startup, overrides, response class, dependencies. Okay, spreadsheets. So what I want is prefix is equal to auth. Is it slash? No, it should be like this. It's going to need to confirm this. So, slash. Okay. So this is how it is. We want a situation in which all the endpoints we are going to instantiate with this particular instance of this API router will have a prefix. So, and the prefix will be auth. So in this case, if our base URL is something like api.twitter.app, all right. So the endpoints that are responsible for registration would be api.twitter.app/auth, then slash the name of the endpoint. I hope you understand me.
Yeah.
Okay. Okay, so this is what I mean. Let's say we want to create a registration endpoint. I'll simply decorate this with router. Can you see this? This will be router.post. And I want post request to register. Now async def register. For now, I want to pass it. So what this will do is that it will this particular endpoint would be the base endpoint, then slash auth, and then slash this register. But since I have already included a slash, there's no need for me to include another slash, so I'll remove them. If we are good to go. Now, one more thing. Because you've instantiated this API router here, it doesn't mean that fast API will automatically understand it, will automatically see it, right? You need to actually register this router at the root of your application. So we are going to come to this root, which is our server.py file. Then we are going to import that router. So from routers.auth import router. Good. Now we can then register this router here. We should register. It's include router, not register. Include router and the name of the router. Now, all right. So with this, if we start off this application, we will be able to see that endpoint. Okay, we have an error. We have an error.
It's talking about that prefix. I guess it has to
You
do
saying
with
the prefix should start with a forward slash.
Um,
Sorry, I didn't get what you said.
yeah, yeah, yeah. So we have a little error And if you look at this error, it's as it prefix dot starts with within fast API that checks that it should start with. Okay, can you now hear? Can you all hear me?
Okay, yeah, I can hear you now.
I hear you now.
Sorry, I was disconnected. I don't know why. Maybe it's my network. So let's go back to it. Okay, I was saying that from this error logs, right, is like there's a checks within fast API that ensures that when you define a prefix, it should start with backslash. So let's rectify that and see. A part prefix must not end with a part prefix must not end with this, as root will start with this. Okay, that means we should remove this and include this here. Good. All right, so our startup is complete. Let me shut it down and then we start it. All right, so the startup is complete. Let us go to this URL and see what happens. I want to inspect the documentation to see if this register endpoint is has been registered, like has been ticked by the app. All right, so if you go to docs, you can then see all the endpoints that we have. So can you see this auto register? This port, this slash port is the prefix that we created there. While this is the register endpoint that we register. That's if we did not register that particular endpoint. The router may know the endpoints. Let me show you what happens if you didn't register the router. Now let's go to server and let us remove this. Good. Now let us go back there and reload the docs again. Yeah. So can you see that we don't have that register endpoint again? So when you instantiate a separate router, all right, you still need to like register that router at the root of the application so that the whole application will know that, hey, I have this router here. Okay, so that is that. That is that. Let's come back here. And we are going to shut down the server. Okay. So the thing is, what we are doing here, it's a little bit problematic. I explain what I mean by that. You know, if we have let me create another router and let me call this router tweet. Okay, let me use contents. Let me use contents.py and of course, we are going to, we also need to register this router as well. Let me say that the prefix here is content. Okay. Now, what if we want to register this router at this point? So can you see the problem we have now?
Yeah, and we have router imported from two different. There's a the name
Yes,
is repeated, so
yes, there's a name
Python
conflict.
won't know which one.
Yeah, there's a name conflict. Yeah, it will be difficult to I think in this case maybe the app would maybe pick the second one or the first one. I don't know. They will need both of them to be registered. All right. So in this case, we'll not just import router. There's what we call import as in Python. So we are going to import router, but we don't want to use it as router. We want it to be port. We want to use it. We want to use it as port router. So the second one we want to call it content router. Right. We are still importing router. There are something else. Okay. So here we will remove that router and then use port router for the first one. Then we are going to register content router as well. Yeah. So with these both routers we register.
I have a question, sir.
Okay, please. What's the question?
Since we're trying to, by importing us, what if will it throw an error if we named the router alt router from the main file itself?
Sorry, I don't understand you. Okay, do you
like
mean
from routers?
If we named it something like maybe alt router?
Yes,
right?
exactly. Yeah. Will it cause a problem? Will it throw an error or something?
It will still work. Yeah, definitely, it will still work. It's just that it's more cleaner to this router so that
Okay.
in each of the endpoints you're using, in each of the modules you're using router.push, router.get, router.that. Then when you are importing, you can then specify.
Okay, I understand. I
But
understand.
if you choose to use this name over there, it will still work.
All right.
Okay, so we've done so many things. So I would love to stop here so that it will not be too much. I believe we've done so many things today. So, so I'm going to comment this code. Then I'll show you how to use black so that we can auto format the code for us instead of formatting it manually. And I think we'll use it to check for possible errors in the code, possible styling errors in the code. So I will commit this. And completed class including. Good. So now we are going to run black to format this. So you see this command docker compression twitter sh -c python -n black line and blah blah blah. So we are going to run that command as make black. See, to go through the codes we've written on it will like reformat it to the standard style. Good. So it has reformatted base, models of base, server.py, contents.py, and all of this. So now let us see the changes to be made. Yeah, it's like okay. this thing was somewhere here. So it created that extra space so that there will be two spacing. Okay. Now a database, it added a comma here. Then let me check it again. Okay, it added an extra space here. Then based by it added an extra space. Contents, same thing. And users, the same thing. So in Python there are like standard styling, right? There are rules and things like not like maybe using too much spacing and maybe using too few spacing and all of that. So Black is like the formatter that it goes through these rules and then formats your code so that it meets the specific block. Now let's use the list. Okay. As you can see, it has returned one message. A database .py file line 47. According to this rule, E501, a line length shouldn't be more than 79 characters. But in this case, we have a line length of 117. So let's go and check. Database .py at line 47. This is to line 47. Good. This particular line. So as you can see, it's very long, right? It's a very long line. So the thing is, why it is advisable to keep your line length below 79. There are certain situations in which you just can't help it. Your line has to be long. Like in this DB URL, there's no way we are going to cut this and it will still be cool. So in this kind of situations, you can tell it not to perform an analysis of that particular line. So you input these comments no cut. At the end of that line, you want it to skip. So if you run that command again, it will not display that error. Good. So we don't have errors again. We are good to go. So I will then commit this. Then I'll push this to Git.
So basically, Flake and Black is just to make us have cleaner code.
Yeah, that's basically what Flake and Black does. What you normally do is you first run Black to correct the errors that are correctable automatically. Then when you're done, you run Flake 8, and some of those things that couldn't be corrected automatically, you can do something about that. Like this particular one we edited, line 47. So that was a very long class. Do we have any question so far on what we've done? Any questions so far?
So far from me,
None from me.
none from me, Sha. Just to rewatch the video and
Just more practice. And,
yeah.
Okay. It's all right. Thank you. Thanks a lot. So that will be that for today. Then in the next class, we are going to round up the registration and authentication. So thank you. And
thank you very much.
Thank you very much.
I will send the question to you on the Slack. On Slack.
All right, so thank you very much.
Okay, it's okay. It's okay. Please screenshot the database configuration and the error that we had.
All right, sir. Thank you.